I will talk about neuroaesthetics. It's relatively a new term, by the way. It was coined by Synesthesia, and I'll mention some of his works during the talk, and specifically on beauty and creativity in the brain. And since it's sort of also a summary lecture, I will try to refer to the previous topics that we've discussed before. So previously, we dealt with different cognitive functions and systems that allow us to perceive various forms of art, music, paintings, visual art, cinema, and we touched even on the narrative. And maybe the one thing that all of these forms of art have in common is that they touch us. Yes, they have an aesthetical component. That's what makes art. And why we have an aesthetic sense, and how did it develop, and how it's represented in the brain that would be actually the topic, topic of this lecture. So I will start by describing principles and origins of aesthetics. There is no consensus on them, so some of these ideas were developed by discussion with Alon, and we will describe whether the aesthetical perception has any reward value. So we all know that we like art, yes, it pleases us, so whether it has a reward value or not. And I'll talk about possibility that a beauty center exists in the brain. So there is a center for vision, there is a center, actually several regions that encode fear, so whether there is a single brain region that encodes beauty. And finally, I will describe some developments on creativity, whether it's possible to boost creativity by various manipulations of the brain, and what is the origin of creativity. So let's start with the principles and origins of aesthetics. So, it's slow. Okay, so while this slide loads, so Hagik now in his first introductory lecture highlighted the fact that maybe one of the things that is attributed to beauty that it's subjective. Each and one of us has its own criterion for beauty. We can agree or disagree whether a person is beautiful or not. And if you look culture in terms of development of beauty stereotypes in culture, and over time, we see that they're very, very different. So. So probably in the first examples of prehistoric art, the standards of beauty had to do with fertility, and later on different religious traits influence the way in which we perceive beauty. And if we look at all these examples, it's really hard to say what was beautiful in different times. Even in the 20th century period, it looks like there is no universal standard for beauty, and probably the beauty, if such thing exists, is masked by cultural and different traits that include fashion. And one example for this is, for example, the skin color. So it was sort of considered to be more aesthetically pleasing to have a white, like not tainted skin at some 100 years ago, because tainted skin was associated with physical labor and working outside in the sun. During the time when the Industrial Revolution changed this idea, because most of the work moved into the factory, so a person is not exposed to the sun, is probably somebody that can't take vacation and has to work all the time in the office or in the factory. And the recent traits with all the health issues that comes with exposure to sun and skin cancer sort of made it again, that's what I've heard, that the fashion now changed it, and bright skin is again popular because it sort of signals that the person is consciously aware of the danger and health issues. And if you think that it's hard to define only female beauty, the same thing is true also for male standards of beauty. Although maybe on the first instant you would think that maybe it would be easier to define what is a beautiful man, maybe somebody strong with well-developed muscles and physical strength, but different examples of beautiful men, this is Lord Byron, by the way, and etc., are not always correlated with physical strength. There are other examples. So is there any universal property that defines what is beautiful, let's say with respect to faces? If yes, it has to be something really evolutionary conserved. And one thing that sort of hints to the fact that yes, such thing exists is the fact that all cultures have this ability, even remote populations have the ability to say this person is beautiful or not. So they have the aesthetic sense. So it probably signals the fact that it's evolutionary conserved.
So
yes?
you say that the beauty is actually objective, not subjective?
So we will try to see if there is any beauty objective criterion for beauty. And if yes, how it's represented in the brain. So that's an open question. Probably I will not provide the definitive answer. This is something that people were, exactly because of the fact that beauty is such a subjective thing, people were arguing about what is beauty for centuries. So if there is something that is evolutionary conserved, the most immediate thing to propose is that beauty is, our sense of beauty is tools that we have in order to evaluate the potential mating partners. And what we propose is that actually, because it's important, evolutionary speaking, that the potential mating partner is to be somebody robust and fertile, etc. So probably what we focus on when we evaluate beauty is actually on the fragile components of forms and patterns, because these are the patterns that are the most easy to break. So it's in a way it's a demonstration. If these patterns are intact, it signals that the subject is potent. It signals absence of diseases, absence of injuries. It signals that it's in the right age. In general, it signals that the potential mating partner is fertile. And this is, if this principle is true, that should be also found in not only in humans but in evolution in general. And maybe the peacock is the best example for that. Since it has such a beautiful tail, it's really it's easy to find defects in it because it's so fragile. Just having slight damage to this tail will be immediately noticeable. Another idea that was around with respect to why it's not related to beauty per se, but it might explain why the peacock has such an amazing tail, is the idea of the handicap principle, or עיקרון ההכבדה, that was proposed by the Israeli biologist Amos Zahavi, and where he claims that such a tail, and there are other examples like the big horns of in some animals, is really an evolutionary evolutionary negative thing, because it really handicaps the animal. So a peacock with such a huge tail is more vulnerable to predators, etc. But since it survived despite this particular individual, despite having such a massive and clumsy tail, it signals the female, despite the fact that I'm sort of handicapped by this tail, I'm still potent and therefore attractive in terms of the reproduction. So if this principle is indeed, and I'm talking about the fact that our attention to beauty is actually attention to, that beauty is actually an attention to fragile elements, then what we will find beautiful is manifestations of intactness of these elements. And probably the easiest way to detect defects, according to this, is by looking at deviations from symmetry. Because if something is not symmetric, and we, as most of the animals have a bilateral symmetry, if something is not symmetrical, it means that it's damaged. And indeed, a lot of patterns that we recognize as beautiful in nature and probably are attractive for the potential mating partners are indeed symmetrical. So in all these cases, the symmetry is exposed. It's immediately noticeable if some deviation from symmetry occurs. So what we will discuss in the next few slides, whether symmetry equals beauty or not. So far we were talking about really sort of hardcore evolutionary biology, but beauty has, we evaluate some human-made artifacts as beautiful, paintings, art in general, not only physical subjects. So this notion of symmetry is actually a very ancient concept in human anthropology, and first stone tools were produced by stone knapping, this procedure of hitting one stone against the other. And about 1.8 million years old, there were already stone tools like that, but they lacked any symmetry. About 1.4 million years ago, symmetrical tools emerged. This is actually the sharp part of the axe. They had some symmetry. It wasn't perfect, but they were already symmetrical. And some 300,000 years ago, we started to find really perfect symmetrical tools. So these ancient tool makers, or maybe even artists, if you would like to call them so, were really paying attention to symmetry and were trying to achieve perfection in that. And there is a whole field in neuroscience that deals with trying to infer from the tools that we find what kind of brain pathways these prehistoric people had by, for example, scanning the brain of modern days stone tool makers and trying to infer which pathways probably existed in the ancient ones as well. And the artists, modern artists, were very well aware of our exceptional ability to detect symmetries and asymmetries. So this is maybe the most beautiful example of this notion. This is a painting by the Hungarian painter Csintvali Koszka, and when you look at the face of this old man, you immediately see that something is strange here, and basically that the left part of his face is different from the right part. So maybe the whole face is a bit thicker, and the nose is not exactly symmetrical, etc. And few years ago, the mystery of this portrait was sort of revealed. So if we look, if you just put a line in the middle of this painting and look at the painting from the mirror, positioned at right at the midline. So if we look at the left part of the painting, what we'll see is this man. When we look at the right part, that's what we see. And Csintvali Koszka was a mystical person, so a possible interpretation of this painting is that God and devil exists in all of us. And maybe this is one of the really best examples of use of these asymmetries in art. So is beauty equals symmetry? And the answer from this Nissan campaign probably that is not. That yes, cross-culturally there is a tendency, and this was tested in various groups, to classify people more or less with symmetrical faces as more beautiful than those with asymmetries, but symmetry per se doesn't equal beauty. So then what is beauty? What is the hidden pattern that signals us that the person is beautiful or not? So if this is not symmetry, so maybe also in artistic examples, in abstract forms, symmetry equals or doesn't equal beauty. So in these experiments, different patterns were shown. Some were symmetrical, like this one, and some were asymmetrical. And the subjects had to judge for each. So sometimes they had to answer for let's say for this particular example if it's beautiful or not, and in other cases they were asked for a different pattern whether it's symmetrical or not. And this is a bit complex slide, but the bottom line is that different maps emerge for aesthetic versus symmetrical judgment. So if we contrast aesthetic versus symmetry judgment, so in other words, people have, these are regions that were active more when people had to say if something is aesthetically pleasing or not. And these are the brain regions that were active more for questions of whether something is symmetrical or not. And these two maps were different. So the cognitive evaluation of symmetry and beauty are segregated in the brain. And one interesting thing is that on top of that, a different area, the frontal medial cortex, which is close to a region that we will discuss later on as a putative center for beauty, the orbitofrontal cortex, was more active for beautiful versus non-beautiful patterns. So this is sort of another proof that symmetry and beauty are not the same thing. So then what is beauty? Maybe beauty is a more general thing, like fertility. And prehistoric art was actually very much focused on fertility. This is an example of one of the oldest sculptures, and you can see that this is probably was probably a fertility goddess. And you can see that all these concepts of fertility is very, very exaggerated in this example. So maybe this is a general characteristic of what we find beautiful. And one of the things that are different between the genders, at least in the Western society, is the waist to hip ratio. So there were many studies showing that estrogen results in fat deposition in women, that results that leads to lower waist to hip ratio than the case in males. And there were many studies that were linking a different ratio of the waist to hips towards different diseases, including early onset diabetes and infertility, and the lack of this disease was associated with low waist to hip ratio. So that's sort of OSP-like figure that the Western society chose as the standard for beauty. And in this paper that was published in Nature, this is, by the way, from an image from this paper that was taken from the American Psychology Association, a remote population that didn't have any contacts with Western media and were not exposed to Western-like standards of beauty, had to evaluate their preference. They had to rate this women that were different in their waist to hip ratio by parameters of attractiveness, healthiness, and the degree to which they could be potential spouses. So these women have a high waist to hip ratio, and these females have a low waist to hip ratio, and they have different weights. So this is the normal weight, this is overweight, and this is underweight. And the preference of the Western male choosers, participants, was to choose this as their model standard. So what happens with this remote population? This is a population in Peru. It's a Yomibato tribe, and here you have the Western males, and here are two different tribes that ethnically are very similar to the Yomibato tribe, but they had various increasing exposure to the Western culture. So they were living nearby the Yomibato, but had much more contacts with Westerners. And this is the correlation of the attractiveness, healthiness, and preferred spouse score to the waist to hip ratio. So you can see that, for example, for attractiveness, the remote Yomibato tribe prefer actually high waist to hip ratio than the Western group, and they also scored the figure with higher waist to hip ratio as also more healthy, and also as more preferred in terms of being chosen as a spouse, while the Westerns were consistently choosing the other type, the low waist to hip ratio, as more attractive, more healthy, and more preferred. While the other tribes had a sort of intermediate preference. And this is interesting for many reasons. First, it shows that indeed our sense of beauty, attractiveness, has to do with evaluation of partners and with evaluation of health of the individual, and because all these parameters were the same. The figure was chosen, the same figure based on attractiveness, healthiness, and preferred spouse. But even more, it says that maybe this waist to hip ratio thing is not a universal principle at all, although the Western society sort of imposes it. And as the authors of this paper claims, that with disappearance of remote population, it will be impossible to actually really understand if this is a universal principle or not, because now we are all exposed to sort of universal media. And what is interesting in terms of, just as an anecdote, the participants of the study had to actually describe the health status of these figures. And while this figure was described as healthy and normal, the Barbie-like low waist to hip ratio was described as suffering from severe diarrhea and probably almost dead. That's a quote from the participant. So whether it's a universal principle or not, whether this tribe is a really outlier in terms of their aesthetical appreciation or not, that's an open question. So let's move for a second to animals and try to see how they evaluate forms, abstract forms. So a very well-known phenomenon is called the peak shift in the following paradigm. So the rat is trained to choose a slightly more rectangular stimuli to get a reward over a square pattern. And after it learns that it has to prefer this over that, in a taste trial, it's either shown with the same pattern that it's been rewarded before, or even more exaggerated, more rectangular pattern, and the choice is transferred actually to the more rectangular pattern. So what the animal chooses here is not between that stimulus versus that. It really actually prefers rectangularity, and the more rectangular the shape is, the more it is preferred by the animal. So this transfer of preference to form is called the peak shift, and another famous related example is the work by Tinbergen, a famous zoologist that found that seagull chicks have an interesting behavior pattern. So the young chicks, they peck on the mother's beak on the red spot here in order to receive reward. To receive food. So he conducted a series of experiments. So first he measured the pecking rate for a natural head, and it was pretty high. Then he replaced the head with a model of the head, and there was still a high rate on pecking. Then he took the model head and removed the beak, and the pecking disappeared. So it was really responding to the beak. Then he removed the red spot from the beak, and there was no pecking. And then when he just introduced a beak with a red spot, the pecking rate increased. But the most striking thing that when he replaced the beak with just a pencil with 3 red spots, the chick started to peck like crazy. So that was like a super beak, a super stimulus. And this led several decades later, Ramachandran, one of the cognitive scientists, the most influential ones that were like dealing with art, to propose that actually art represents a peak shift principle, at least different forms of art, like this erotic Indian art, and probably also our Western beauty standards. So in a way he says that maybe if you put a seagull, make a gallery, an art gallery for seagulls, so what they would put in the middle of the gallery would be this huge stick with yellow stick with huge red spots on it, and that would be considered to be beautiful because that is the super stimuli for stimulus for the neurons. And probably also when we go to the abstract art gallery and we see this red square over a blue background, maybe that's sort of a super stimulus for our certain neurons in our visual system. But it is more evident with more complex forms of art. Well, I don't say that abstract art is not complex, but so he suggested that basically these figures that are very feminine and give us sort of a pleasing effect, it's actually exaggerated subtraction of the male form from the female form. So you subtract, so you get the difference between the male and the female form and exaggerate it, and that's what you get. So he suggested that basically all art is a form of exaggeration according to this peak shift principle. All art is a caricature, in other words. So that was a general statement about art, but let's come back to beauty. Beauty is also a sort of caricature of the normal average face that was exaggerated, according to the peak shift principle, along certain relevant dimensions. So maybe relevant dimensions for assessment of all these physiological traits like age, male to female differences, maybe it lies along certain features like eyes, lips, nose, ears. So for example, I actually don't know if this is true or not, that females have slightly bigger eyes and lips than males. What is known for sure is that as we grow older, some parts of our face continue to grow, like nose and ears. So it can be used as a way to assess age. So maybe a certain combination of this, that's what produces the universal beauty standard. So for that, a prerequisite is that actually there is some coding of an average face in the brain. And different works that study from several years ago in Nature, and next study I'll show, actually hint on the fact that indeed a code for a representation of an average face exists in the brain. So this is done in monkeys. These are single neuron recordings in one of the face patch areas. And so this is sort of a normalized face. There are computer algorithms that can get sort of average face. And then you start to exaggerate it along one of the dimensions, and you get that while the neuron response has a baseline response to the average face, as you exaggerate it, as you move away from the average face representation, the neuron starts to fire more. So these neurons actually detect deviation from the averageness of the face, and this was proposed as a mechanism of general face recognition that I described a little bit, and Alon was talking about in previous lectures with respect to this particular sensitivity of our brain to faces. That basically we recognize that this is my neighbor and this is my PI, etc., by subtracting the different features that each of these individual faces possess from the average face that we store in our memory. And this might explain also why we habituate to beauty, or even more, habituate to ugliness. So somebody can be perceived as ugly in the beginning, and probably we all experience that. And as we sort of live along the person, we habituate to it. So maybe the norm, this average face that we have, is changing. So another sort of piece of evidence is this another monkey physiological study coming from the Tsao and Livingstone group, which actually Doris Tsao was the one who described the face patch areas in the monkeys, and I was already describing some of her results. So what she found that there are neurons tuned to different. So if there is these different parameters of faces. So for example, I'm sorry that it's hard to see. For example, eyebrow width. Well, the hair width, eyebrow slant, inter-eye distance. So, for example, here you move from almost no hair to large to wide hair width. Eyebrow slant from negative eyebrow slant to positive eyebrow slant, and this is the inter-eye distance from very closely positioned eyes to distantly positioned eyes. And there are all other types of parameters. So you can see that the neuron is responding to a particular combination, to particular features. So it's, in this case, it's responding to inter-eye distance, to iris size, etc., and doesn't care about others. And the more you go along this direction, the more this neuron responds. So indeed, and if you think in terms of population coding, the different neurons have different preferences like that. And together they can be sensitive to deviations from this average phase. So if beauty is indeed an exaggeration from a deviation from the average phase along the relevant dimension, then maybe a peak shift of the beautiful phase, exaggeration of the beautiful phase, will be even more beautiful. But this is probably not the case. So this leads to the following conclusion. Either beauty is something else, is not a kind of ordered, coherent deviation from the average phase, or that the peak shift principle has a limit. So you can go and become more and more beautiful. Let's say, and I don't want to focus on this particular example, but bigger eyes, bigger lips, smaller nose. But at a certain point, if you go, it becomes a caricature. It's not beautiful anymore. So this is one of the ideas that we would like to propose. So that's the first part on the principle and origins of aesthetics. And as we probably all know, art and aesthetical experience is often rewarding. We go to concerts, we go to art galleries, we enjoy it, we feel really rewarded for doing so. So is it indeed activating the reward circuits in the brain? So two areas that I'm going to talk in this part is the orbitofrontal cortex, is the region of the frontal cortex positioned behind the eyes, behind the orbits of the eyes. It's receives inputs from all sensory modalities, including visual and auditory, and this is important because this region was, I will actually jumping forward, this was the region that was proposed as the center for beauty for both musical and visual beauty. It's strongly connected to another region that I will talk about, the nucleus accumbens, that's part of the reward system. And the pathology of the orbitofrontal cortex involves actually a poor judgment of evaluation of rewards. So for example, one famous task is when the person has to prefer consistently a less rewarding stimuli, in this case a deck of cards, which brings low reward but consistent rewards versus a high rewards which comes also often with losing. So the orbitofrontal cortex was associated with this condition, with the correct behavior in this task, and also people with damage to orbitofrontal cortex were reported to have absence of regret feelings. So its putative function was proposed as calculating the value of a reward outcome by assessing the trade-off, the utility, and comparing with other potential reward outcomes. The other area that the orbitofrontal cortex connects to is the nucleus accumbens. It's part of the reward circuitry. It connects strongly to the ventral tegmental areas. It contains dopaminergic neurons and to the prefrontal cortex, and it is involved in drug addiction, depression, actually the euphoric feeling during cocaine addiction is associated with release of dopamine in this area, and it was also a target for ablation surgery as a treatment for alcoholism in China. So it's basically a center that is considered to be a reward mediator. So if aesthetical experience is linked to reward, then probably we would expect that these centers would be activated when we experience or evaluate beauty. So in this study, subjects had to heterosexual subjects had to evaluate attractiveness of photographs of the opposite sex. And two areas were highlighted. They were correlated. The more attractive the photograph was, according to the subject report, the more activation was in these areas. So one was the nucleus accumbens, and the other was orbitofrontal cortex. It was interesting that the orbitofrontal cortex was linked to higher evaluation rates only in males. And that led the authors to suggest that this sex difference in orbitofrontal cortex activity may provide a potential mechanism underlying the reason why men identify attractiveness as a stronger motivation in mate selection. So sort of it's more involved in the decision making, while on the reward level, the nucleus accumbens is activated both in males and females. So, so maybe beauty is just a reward. Something that is beautiful is something that we define as rewarding or as potentially rewarding in the future. So one way to dissociate between these two was the idea, I think is quite elegant, was published in Neuron 10 years ago. So again, heterosexual subjects had to evaluate beautiful female faces versus average female faces, and also beautiful male faces versus average male faces. And they were scoring the beautiful female and the beautiful male faces. This was done in males as beautiful. So the males considered both female and males, certain types, as beautiful. But then this was dissociated from the degree to which they were attracted to this subject. And that's what measured by actually key pressing. So in order to keep the same photograph for more time, they had to press certain combination of keys, otherwise it will change. So it was found that males press more only for what they define as beautiful females, but not for what they define as beautiful males. So there is a difference between beauty, aesthetical appreciation, and attractiveness. And what these authors found, that the degree of activation of reward areas was not going along the aesthetical judgment of beauty, but actually was going along the attractiveness of the degree of attractiveness. So at least for female faces. So the nucleus accumbens was activated more for beautiful female faces than the average male, than the average faces, but beautiful males were not activating more the nucleus accumbens, maybe even the other way around. So this probably suggests that reward circuitry per se does not include aesthetical judgment. So beauty is not reward per se, at least our evaluation of beautiful faces. Yes?
What about homosexual subjects, for instance?
Well, I don't know. Yeah, I would expect that yes, but I'm not aware of any study that. There is actually a handful of studies that were. This is a new field, so maybe more studies will come. But at least this dissociation between attractiveness and beauty, I think, hints that it really follows the attractiveness and not just abstract concept of beauty. So speaking of abstract concept, art, we can consider art as beautiful, but it's not necessarily something attracted that is attractive, at least in sexual terms. So in this study, a comparison between art and non-art was evaluated, and interestingly, the orbitofrontal cortex, the ventral striatum, which is the nucleus accumbens is part of, and the cerebellum were linked to viewing art versus non-art images. And the authors sort of claim that it's a well-known principle in design that if you link a certain product with artistic component, the consumers evaluate it as more expensive and more like a better product than just a non-artistic one. So they claim that not only these areas responded to art versus non-art, the art images has also a reward value. So regardless of that, it shows that in this sort of pure aesthetic judgment, a reward area is involved. So what about aesthetic preference for painting in general? So in this study, the subjects were shown with different stimuli. In this case, a painting by Van Gogh, a painting by Kandinsky, a painting by Gauguin, and a painting by an abstract painter that I never heard of. And the images were either original or were altered. For example, here in the Kandinsky painter, one of the dots, of the 3 dots here, was moved or filtered. So those who've been to Dori Deldikman's lecture will know that for at least those, if the concept that probably Kandinsky wanted to express, this change might be big, at least if the subjects were aware of it. So and the subjects had to rate the different original or the modified paintings, and the degree of this rating was associated with activation in other regions, those that we discussed before. One of that is another region of the reward circuitry, the caudate nucleus, and actually this region is involved in depression. And the low was when the preference to paintings was low, so the subjects didn't like the painting. This region had a reduced activation, and as they liked the painting more and more, the activation was more and more approaching baseline. In another region, the cingulate sulcus, here the activity was increasing with the preferred, as the subjects preferred the painting more and more. So the bottom line of all these 4 studies that I presented, that maybe the reward area is associated with aesthetical evaluation, but if this is the case, it's not one single area that is doing so. So okay, so let's continue for maybe another 10 minutes and then take a break. So far we spoke about paintings and visual response to either art or human subjects, but another modality that is really pleasing for us humans is music. And Ronnie Granot in her lecture sort of described music as a cheesecake, this artificial product that although we were not exposed to it, like evolutionary speaking, to modern music, we still very much enjoy it, and probably it hints that it has evolutionary role. So some people enjoy music so much that they have experiencing chills, these tremors when they hear their preferred musical piece. And in this study, the subjects were asked to bring their favorite musical pieces that really touched them to the scanner, and their brain was scanned while they were anticipating these chills and actually experiencing the chills. So using a technique called positron emission tomography, where you actually can follow after neurotransmitter concentration in the brain by by introducing a chemical agent that binds this neurotransmitter, it was found that in the nucleus accumbens, during chills, there was a reduction in the signal, which actually indicates that there is increase in the secretion of dopamine to the area during the chills. So that was bilateral in the left and in the right nucleus accumbens. So during chills, this subject really had release of dopamine into the area, and in a way similar to what happens in these euphoric moments in cocaine addiction that I mentioned before. And these two regions, the nucleus accumbens and the caudate nucleus, had different activation in the different phases. So the caudate nucleus, also called the dorsal striatum, is more active during the anticipation towards this intense experience, and the right nucleus accumbens is active during the chill itself. So music is really rewarding. The question is to which extent it is rewarding. If it's rewarding, we can pay money for such reward. And while preparing on this lecture, I discovered that actually the Paul McCartney's concert in Tel Aviv was the most expensive concert in Israel. People were willing to pay 500 shekels for standing places and 1,500 shekels for sitting in the concert. So people really can pay, are willing to pay money for experience of music. And this study actually checked in the scanner the subjects were listening to novel musical pieces, and then they were asked how much money they are willing to pay for each of these musical pieces to buy it. And it was found that again the nucleus accumbens and the caudate nucleus, these two regions involved in reward, were activated more during listening to the musical pieces that were later on the subjects were willing to buy. So they were really experiencing sort of a reward related activation, and this is how it looks during time. So there is increased activation in the right nucleus accumbens and the right caudate for pieces that the subjects were willing to pay for, versus pieces that the subjects refused to pay for. So music is really rewarding. So other forms of art, are they rewarding or not? And maybe not even art, just perceptual experience is rewarding. For example, well, probably all familiar with this illusion. Somebody doesn't all see what is here. Well, if somebody doesn't, it's the Dalmatian dog, and usually people experience it all of a sudden. So you once you see the dog, it's impossible not to see it anymore. And Ramachandran proposed that this binding and grouping principle that Dori discussed in his lecture is actually so strong that we can't get rid of, because once it's there, it's associated with reward activation, limbic activation, because maybe the ultimate function of the brain is to achieve understanding of the world around us, and this understanding is rewarded. So maybe also a more complex arts, which involve semantic knowledge and actually understanding of the art form, is rewarding because of this sort of solving the riddle of the art piece. Which is also rewarding according to Ramachandran. And then finally, another thing that is linked to, might be linked to reward is that novelty and surprise are probably rewarding as well, and this is seen in art and particularly in fashion, that probably the reason why, while deviation from standard shape into more extravagant forms, breaking the symmetry, changing the proportions, and going from classical to really colorful designs we find it beautiful because it's novel and surprising, which is the things that might be linked with reward. So maybe beauty is associated with reward. So let's take a break, and then we continue discussing whether a beauty center exists in the brain. So after dealing with the topic of existence or absence of aesthetical principles, which we saw is a sort of complex topic by itself, because it's hard to pinpoint one universal aesthetical principle, we'll go to even, just a second, to even a more sort of challenging question of whether there is a beauty center of the brain, although we sort of failed to define beauty in objective meaning, but maybe despite absence of one single universal objective criteria for beauty, there is a physical center that still does the subjective evaluation of beauty. Yes?
Yes, so I wanted to ask you whether there was any study done about beauty and complexity, whether complex patterns appear to us more beautiful than, because I could imagine that like we saw these tools and they become over time not only more symmetrical, but they also become more complex, right?
Yeah.
As well as all kinds of art.
So the only studies that I'm aware of is the ones that I presented in the beginning, where symmetrical versus beautiful patterns were compared. So these are not tools; these are just geometric patterns. And well, as you've heard, the answer is that symmetry and beauty is different. So if you replace beauty by complexity, maybe you can ask the same question. But I'm not aware of studies that deliberately address this point. But yes, that's like if art piece or just a general phenomena is a riddle that the brain solves, and maybe the more complex the riddle is, and if we succeed, the more rewarding and the more beautiful it's. I mean, we are familiar with, in mathematics, some equations seem to us beautiful, after we realize the complexity and the power of this concept. So maybe these things are indeed related. So a beauty center in the brain. So Seymour Zeki, that as I said before, is the sort of the founder of the field of neuroaesthetics, or at least the one who defined it, and he's a professor of neuroaesthetics. Actually, there is this formal title. So he came with a series of papers recently trying to identify this locus in the brain that is a universal evaluator, or at least is correlated with evaluation of beauty. So the way he did it, he said, okay, beauty is not only visual effects, also music elicits beauty. So let's go for an area that is highlighted for beautiful visual stimuli and for beautiful musical stimuli. So first, subjects had to rate the different stimuli according to whether they're ugly, neutral, or beautiful, and then the correlation of this evaluation was tested in fMRI. So several regions popped up for visual beautiful stimuli. One of them, the strongest activation, was in the orbitofrontal cortex that we discussed before, and it was also active for musical stimuli. That's the same brain shown from different sections, and if you superimpose the visual and the auditory activation for beautiful stimuli, which the subjects define as beautiful, we see in yellow these regions for conjunctive visual and auditory beautiful activation, which coincide with the orbitofrontal cortex. And the relationship was linear, almost linear for both the visual stimuli and the musical stimuli. So beautiful stimuli of both modalities elicited a stronger activation in the orbitofrontal cortex, and the more uglier were the stimulation, the less activation was in this area. Ugliness per se, however, was correlated with different regions. Increasingly ugly visual stimuli were actually eliciting activation in the amygdala, this region that is mediating fear response, which actually makes sense. We see something ugly, visually ugly, usually it's something that also, often it's something that scares us. And auditory ugly stimuli, so unpleasant auditory stimuli in a way, were eliciting activation in the somatomotor area, which also makes sense because probably if you hear something aversive, you want to move away from it. So while orbitofrontal cortex was suggested here as the beauty center, and the paper is entitled towards brain theory of beauty, the ugliness is correlated with other regions. If you remember the lecture by Hagi Knan, when he defined what is aesthetical judgment, he referred to this Kantian notion that while perceptual judgment is something objective, aesthetical judgment is by definition a subjective thing. So I can say that the sunset is red, and this is an objective perceptual property of the sunset, but I can say that it's beautiful, or it brings some sadness, or etc., which will be my personal subjective response. So Kant was saying the following: if we wish to discern whether something is beautiful or not, we do not relate the representation of it to its object by means of rational understanding. The judgment of taste, in other words, aesthetical judgment, therefore is not a cognitive judgment, is not logical, but is aesthetic. And he adds, every reference of representation is capable of being objective, even that of sensation. So in other words, sensations are objective. I feel pain, and that's, although I report as a subject of it, it's linked to some objective property. The one exception to this is the feeling of pleasure or displeasure. This denotes nothing in the object, but is a feeling which the subject has within itself, and in the manner in which it is affected by the representation. So this distinction between perceptual judgment versus aesthetic judgment is crucial if we want to define a beauty center in the brain. Because if it's really something that is dealing with beauty and beauty only, it should not be involved in a sort of lower level of perceptual judgment. And in a paper that was sort of continuation of the paper I showed you before by the same authors, it was published, I think, last month. The aesthetic judgment was compared for perceptual judgment. And the subjects were shown to stimuli, and they had to be compared for which one of them is more beautiful, and afterwards whether they are which one is brighter or not. So beautiful is aesthetical judgment, brightness is a perceptual judgment. So first of all, the stimuli, there are different types of stimuli. Some had scenes and they elicited activation. That's not contrasted yet to beauty or brightness, just the stimuli itself elicited response in the parahippocampal areas, these areas that are involved in perception of space. That's something that I described few months ago with respect to perception of space in paintings. And the faces elicited activation in the face areas, in the fusiform gyres that Alon was mentioning, and in the amygdala. So what about the aesthetical versus perceptual judgment? So these are the regions that showed increased activation for aesthetical versus perceptual judgment, and one of them is the orbitofrontal cortex, this putative beauty region of the brain. But there were other regions like the somata, the sensory motor areas that I showed before, the cerebellar area, some of the reward areas, the globus pallidus and the putamen, and also the amygdala. So contrary to what was shown before, that it's really the medial orbitofrontal cortex, which is the nucleus, that's the area, it's not the nucleus, it's the cortical region, that is responsible for beauty. It seems here that there are other regions that are involved in this comparison, that are that differ between aesthetical versus perceptual judgment. But orbitofrontal cortex is still one of these regions that is dealing more with aesthetics than with perceptual judgment. And the authors sort of proposed a scheme, just mentioned briefly, that there are two pathways, one involving the orbitofrontal cortex, involving the aesthetic judgment, the other one involving the perceptual judgment. And on top of that, there are two motor pathways which are associated with this evaluation, with this sort of judgments. So interestingly, 4 years ago, there was another study that showed that actually came with similar paradigm, but actually extended it. So in this experiment, subjects were shown faces, and they had to rate the face from very unattractive to very attractive. Then they were presented with a sort of moral goodness judgment. So they had to judge, in this case, the sentence, "He rescued an abandoned dog." They had to judge it from very bad to very good. And then they had to judge, as this was the control, whether something is bright or not, very dark or very bright. And guess what? The orbitofrontal cortex was active for the attractiveness judgment. So the more attractive was the stimuli, according to the participants, the more activation was in the orbitofrontal cortex. But the same region was also active for moral judgment. So the higher the sort of the goodness rating, the more the better was. Well, it was better. It's the gooder. Well, I don't know if such word exists, but the more sort of moral was the judgment, the more activation in the orbitofrontal cortex was shown. And this didn't happen for perceptual contrast. So different brightness didn't elicit a special response in the orbitofrontal cortex. So the conclusion here is either goodness and beauty are related, or that orbitofrontal cortex, as was shown in many studies before, is just is a region that is dealing with complex decision-making processes, not just perceptual, but some complex evaluation of reward and probability of rewards. And by the way, these properties, the goodness and the beautifulness, were highly correlated, the response in the orbitofrontal cortex. To conclude this short part on whether there is a beauty center in the brain, and the topics that we touched in the first part of the lecture today. So there are several evolutionary and culturally conserved beauty principles in the brain. That's what we propose. One of them is probably symmetry. Whether the waist to hip ratio is something universal or not, that's a debate. Some aesthetic experience, both visual and auditory, result in activation of reward and motivational neurocircuits, thus highlighting their possible adaptive evolutionary origin. So if something is linked to reward so strongly, it means that it's probably has really an adaptive value for us. This is linked to the Ronnie Gronot talk about what is the adaptive value of music. And this is probably can be generalized to other forms of art, including maybe complex art that you were mentioning. But not every aesthetic judgment is linked to the reward system. This example with the fact that male participants were scoring, were defining beautiful male faces, but were not attracted to them, and therefore their reward system was not activated. This is kind of a contra-example to that. And it remains to be tested whether the orbitofrontal cortex represents the beauty, the ultimate beauty center in the brain, or, as I said, it's just a region involved in complex or maybe abstract evaluation decision task. Or maybe, as Kant said, that there is nothing that makes me wonder so much as the starry sky above me and the moral law within me. In other words, according to Kant, beauty and goodness is the same thing. So maybe the orbitofrontal region is sort of a kind of Kantian center for beauty, and I'm sure that if this is the case, the church will be very happy to hear that. And finally, aesthetic judgment involves other perceptual categories. According to like the philosophical definition of what is aesthetics, aesthetical feeling is everything that is beyond the senses and can be modulated by cognition, but doesn't have a real objective value. So for example, a feeling of sorrow, I can be touched by something, I can be moved by that, but that will be my subjective aesthetical feeling. It doesn't necessarily involves a sensation of beauty. It's just other type of emotion, and it'd be interesting to see if that sort of aesthetical experiences have similar or different mechanisms to those described for paintings and music. So the next sort of subject is whether there is a cognitive basis for creativity, whether all this beautiful mind and beautiful brains that creates all these sorts of art has a creative principle in it. And one of the things that was maybe the thing that is most linked to creativity is synesthesia. So the example above is how synesthets this is graphem to color synesthesia, the perception of letters and numbers as with colors. That's how a synesthete of that sort, of that type, will read this phrase or this number. And like kind of one funny anecdote, there was this girl that was telling her father that as she writes the letter R and she adds this diagonal line, the color of the letter P changes from pink to blue. And so that's an example of a synesthetic experience. And this is another example of graphem to number synesthesia. So people often view numbers as sort of special, in a special arrangement, sometimes with different colors, and many famous people were synesthetes of that sort, like Nabokov and Feynman, etc. This is an example of month to color synesthesia. So that's how this synesthetic person perceive the months, different months of the year. It's kind of a spiral with different colors. And there is also a rare type of synesthesia, the mirror-to-touch synesthesia. So these synesthetes feel that they are being touched when they see someone else being touched, and this is related to what I described, the mirror neuron system and the empathic brain. But while normally we just see a mirror response without the actual sensation of being touched, unless in some extreme cases that arts bring us to, like in movies, these people experience it on an everyday basis. And the basic sort of mechanism of synesthesia that was proposed that synesthesia results from unusual rewiring of the brains, so different brain regions that are not normally talking to each other. For example, the numeric regions in the parietal cortex becomes linked to the visual areas in the occipital lobe, for example, and that creates this link of unrelated concept, and this is basically what metaphor is. Yes, right? Metaphor is bringing two unrelated concepts and bringing them together. So this is, synesthesia is probably the ultimate brain metaphor. So whether it relates to creativity or not, it's a question. Ramachandran was proposing that depending on where and how widely in the brain the trait was expressed, it could lead to both synesthesia and to a propensity towards linking seemingly unrelated concepts and ideas, in short, creativity. This would explain why the apparently useless synesthesia gene has survived in the population. That's Ramachandran. And there were several reports that synesthetes are more engaged in art. There are more synesthetic students in art schools. There are, of course, many examples of like famous composers. So Liszt and Rimsky-Korsakov, for example, were arguing about the exact colors of the different keys. And so there were synesthetes, often musicians sort of hear see the colors of the different notes. So this synesthesia is one thing that was suggested to link to creativity. Another thing is dyslexia, and maybe one of the interesting examples is the artist Chuck Close. So he was dyslexic, and as well, I guess he still is. And as a kid, he had trouble reading, but he liked to draw. And on top of that, he was prosopagnostics, so he couldn't recognize faces well, identify faces, conditions that Alon was describing before. And his art sort of evolved from his method of how he was recognizing faces in everyday life. So he was sort of deconstructing the face into different features in order to try to identify who is the person in front of him. And he started painting in this way by painting portraits in a pixel-like manner, in which in each pixel he was introducing different geometrical shapes, and this created these magnificent portraits that he became famous for. This is an example of how sort of developmental condition leads to very unusual artistic style and very creative one. And again, there were links. It's claimed that dyslexic people have more tendency towards art. What's the causal direction of this? Whether they move to art because of certain experience difficulties in other fields, or vice versa, is of course an open question. So another involvement of different brain conditions and the link to creativity comes from studying damage to the different parts of the brain. And Alon described patients that drew more more precisely after certain lesions that they experience, but drawing more precisely and being more obsessed with the details is not necessarily creativity. Maybe it's actually the opposite of it. And the idea in general that's sort of kind of the dominant idea is that the right hemisphere is the creative hemisphere, and the left hemisphere is the sort of the logical, the analytical one, and the left hemisphere inhibits the creative right hemisphere. And like one of the key evidence to that is that right hemisphere responds more to novelty than the left hemisphere. And people who suffer dementia, especially in the prefrontal areas in the left hemispheres, often start, well, not often, but there were several reports of that, start to become facilitated in their creative talents. Usually these are people who had talents before already. And also the same holds for brain damage to the left hemisphere. And correspondingly, damage to the right hemisphere results in loss of artistic sense. One example of a person who suffered from dementia affecting preferentially the left hemisphere is that of an art school teacher, Jensi Chang. So as her dementia progressed, she became she sort of moved away from the realistic style and started to paint in a more bold, more creative manner, resulting in this interesting paintings. Another window into the creative brain is what happens in autism. These special cases of autistic savants, these children who are disabled in many functions but are sort of genius and way above average in other. Usually it's restricted to several categories involving painting, numerical skills, and playing music. It's rarely composing of music, but usually it's performing music, usually on a piano. This is a famous case of the autistic girl Nadia, who was the psychologist self-published a book and a follow-up of this book. So this is a drawing of a normal child of 5 to 8 years old, and this is a horse drawing by Nadia at the age of 5. So she was obsessed with horses. She was drawing horses a lot. This is her drawing, I think, at the age of 3, and this is the corresponding drawings of age-matched normal children. And what is and this is a sketch by Leonardo da Vinci. So what is the most interesting thing, that while she was drawing this very, very vivid, very natural, very impressive paintings, her verbal skills almost didn't exist. So she was not verbal. She from what I heard, from what I read, that as her with age, she did manage to develop certain verbal abilities, and this was correlated with decrease in her artistic abilities. So that's again favors this idea that the left hemisphere, the verbal hemisphere, once it becomes more developed, it sort of inhibits the creative right hemisphere. And this ability to draw extraordinary and vivid images without having sort of a normal mind, without verbal abilities, also challenges the hypothesis of the famous art historian Gombrich, that was stating that the fact that we have images of these very elaborate images of animals in prehistoric caves, this is from the Chauvet cave, drawn probably some 30,000 years ago, hints to the fact that already 30,000 years ago, humans had evolutionary, modern, developed mind. They were like us in terms of the mind. But the fact that a child that could not speak, that didn't have any verbal abilities, still managed to draw such beautiful horses, maybe links, suggests that the mind of these prehistoric people was still evolving and was not mature yet. One of the things with creativity is that often it's really hard to say where it comes from. So there were several stages proposed. There is the preparation period, the incubation period, and then a creative insight that sort of characterizes the creative process. And the key thing here is that a lot of creative experiences are often reported as unconscious. So the subject suddenly experience a creative insight, sometimes without consciously thinking on the subject. So this was tested in two related studies. One was published in Science 2006. So in this work, the subject had to choose between different products: a shampoo, a CD, shoes, plane ticket, camera, and room. It's sorted by the complexity of the choice, so it's easy to choose a shampoo in the supermarket. It's less easy to choose what room to rent in which apartment to rent. And there were two conditions. In one, the subjects were presented with the different choice options, and they had few minutes, I think about 3 minutes, to think about it and then choose. Or they were presented with a different list, but then these 3 minutes they were distracted. They had to do some other tasks that prevented them of consciously thinking about their choice. And it was found, and this study was replicated in various other paradigms. It was found that for simple actions, the post-choice satisfaction was higher for conscious choices. So you're more satisfied from the choice of which shampoo to buy if you have conscious time, a time to consciously think of what you're going to choose. But for more complex decisions, such as buying plane ticket, a camera, or a room, it's better if you stop for a second, do something else. In the meanwhile, there is unconscious sort of processing, and then you come up with an answer. And the idea was that maybe while conscious thinking is sort of sequential linear thinking, the unconscious thinking involves parallel processing, which is better for more complex evaluation. So how does it link to creativity? So the same authors were tested subjects for sort of creative solutions. So they had to, in the similar paradigm, they were presented with a task, for example, to make a list of places starting with the letter A, or things of different things one can do with a brick. And then they were either given conscious time to give the answer, or the subjects were engaged in a distraction task, and then while they had unconsciously thinking about it, probably, and then were asked to give the solution. And in both sort of tasks, the result, the answer, for example, the list of things beginning with A, was much more richer and variable and creative if they had unconscious time to think of. So this sort of links the fact that suggests that creativity involves a subconscious processing. And one of the things with subconscious processing that sometimes the solution comes as an insight, the aha moment. For example, as in the case of the Dalmatian dog, you don't see it, and all of a sudden, all comes together, and this aha moment, you realize it, and you see it, and this is associated, as Ramachandran suggests, with increased satisfaction, with increased reward. So, if creativity is linked to the right hemisphere, so maybe the insight moment is also associated to the right hemisphere, and this is a combined fMRI and EEG study. I present only the fMRI part of it, in which the subjects were presented in the scanner with a task that could be solved either systematically or with the creative insight. So they had, for example, to combine, to find a word that can combine with all of these three words. So, for example, pine, crab, and sauce, the answer is apple. You can get a pineapple, a crab apple, and an apple sauce. And you can work on this systematically by trial and error, kind of going through a list, or it just comes all of a sudden, an apple. Yes, so and the subjects had to then report if they came to the solution by insight or by systematic working. And in the case of insight versus non-insight mode of solving the task, the anterior superior temporal gyrus in the right hemisphere was consistently active. So during this aha moment, the anterior superior temporal gyrus was active, and actually it was even active a bit before the aha moment. So indeed, this creative insight is linked to the activity in the right hemisphere. So if the right hemisphere is the sort of creative center of the brain, the creative part, so maybe, and it's according to this hypothesis that I presented before, it's constantly inhibited by the left hemisphere. So maybe if we remove the inhibition of the left hemisphere, we will get emergence of creative talents in normal subjects, as happens in subjects with damage or other neurological conditions to the left hemisphere. So the person who is doing these experiments or creating savants for a day is Alan Snyder from Australia. So savants, as I said, there are different types of savant-like abilities. One of them is drawing. The other is numerical skills. So Oliver Sacks described these twins, these autistic twins that had exceptional numerical skills. So, for example, when matches were falling from a matchbox, they both, in the same time, within a few seconds, they say there are 123 matches on the floor, and they both give the same answer. So that is a similar task to this match counting. So the subjects had to say how many dots are here. And while they're doing that, their left hemisphere is subjected to transcranial magnetic stimulation, TMS, which is a technique which sort of induces a magnetic, through a magnetic field, induce currents in the brain. Sometimes it can be done also for deep areas, and you can either inhibit or activate the area, and this is actually used as a treatment for depression. And using this TMS technique, the left hemisphere was transiently inhibited. And the authors reported that normal subjects after TMS treatment had improved scores in this task. Another example, they were, again, subjecting people to normal individuals to TMS, and they were asked to draw, in this case a dog. So this is a practice. This is actually not from the paper. I couldn't find images in this paper, but that's actually from a blog of a person who was one of the participants in this study. So that's his normal drawing of a dog during practice. This is before the TMS. This is during TMS. And this is some 45 minutes after TMS. So the claims that as a result of TMS, the drawing capabilities, the variability, the richness increase. So Alan Snyder is sort of the advocate of making a creative cap, so everyone will go with a little helmet, and if at a certain point during the day you're stuck and like no creative ideas are coming, you put it, you get some 15 minutes of transcranial magnetic stimulation, and you suddenly get a creative insight that will help you to go through the day. Yes?
Does it last for longer if someone is, the subject of the experiment once? Does it help further to evoke this?
Yeah. So, for example, in the case of depression, this is done clinically, and in the case of depression, subjects are going, depends on the severity of depression. Sometimes once a week, sometimes every day. But the idea is that it lasts for the whole day afterwards, or even for more than several days. So in the case of depression, the idea is that you get also change of the neurotransmitter levels. Here is more dealing with inhibition of the left hemisphere. So I expect that the duration will be shorter. I think in this case the after is 45 minutes after. I'm not sure if they tested for like several days afterwards.
What would be the side effects if someone used this helmet?
I believe personally that enormous, but because although you can make focal sort of inhibition, but all your linguistic many of your linguistic skills are in the left hemisphere, and if a left hemisphere is involved with rational judgments, your evaluation of the world can be maybe very creative, but I don't know.
To do it once or twice, just later on, people while learning or while thinking could just remember or evoke this feeling of having one lobe suppressed or whatever, and then it could help to reach.
Yes, well, I think personally the best is like right after lunch, when I personally feel creativity is really dropping, so 15 minutes and you're back on track. So, but that's really, you see the years, it's really ongoing. Maybe something will come out of that, but yes.
Does someone maybe know why the suppression of the temporal lobe causes this? I mean, is this an increase of activity in the right areas, or is there always a level of activity that just gets expressed more? I mean, what's the mechanism behind the phenotype?
Yeah, well, I'm not familiar with studies. I don't know if there are any that were actually scanning the subjects in fMRI right after TMS. It's impossible to do it during the TMS stimulation, so I cannot answer you definitively, but the general principle that it evokes it evokes currents in a relatively focal area. It depends on the strength of the stimulation. So it's not a suppression per se, just sort of abnormal activity. And to which extent it spreads, I believe that very much depends on which area exactly you stimulate. So, yeah, if sort of activation of the right temporal, well, probably you you might, if it's just not functioning, you might get a boost. If it's just functioning normally, but there is some inhibition from the left hemisphere, maybe there will be no change. But it's really pure speculations, because I'm not aware of a study that stimulated in the right hemisphere and looked for emergence of artistic talents. Yes. So, well, maybe to say it in different words, it's easier to disinhibit an area with this technique than sort of interfere with the functioning with the normal functioning of an area, because every stimulation like this is a perturbation. So to conclude this part, several conditions such as synesthesia and dyslexia are linked to enhanced creativity. Artistic ability, especially drawing, might anti-correlate with verbal abilities, and this sort of propose interesting questions with respect to development of the brain, evolutionary speaking. Creative insight, this aha moment, is associated with the right hemisphere. Inhibition of the left hemisphere results in facilitation of creativity and emergence of savant-like abilities. So this is it, and thank you for coming to this course. If you have other questions on this topic, or maybe something related to the final assignment, we, by the way, posted it, and it has to be submitted somewhere in the end of July.